Hey guys, Dean Chase here with another geometry lesson for you. Hope you guys are all doing good. Yes, I shaved my beard. Go ahead, make fun of me. I look like a little boy. Anyways, let's go ahead and get started with a word of prayer. Dear Heavenly Father, I want to thank you for today, us, Lord. Thank you for all you do. Thank you for this opportunity. Please help me do my best. We love you, Lord. In Jesus' name we pray, amen. Hi guys, so today's lesson we're going to learn how to find and use slopes of a line. This is lesson 3.4, page 171. Let's go ahead and get started. The slope of a non-vertical line is the ratio of vertical change, rise, to the horizontal change, run, between any 2 points on the line. If a line in the coordinate plane passes through points x sub 1, y sub 1, and x sub 2, y sub 2, then the slope m is m equals rise over run, which is the change in y over the change in x, which is y2 minus y1 over x2 minus x1. A lot of words. I'm going to go ahead and show you guys the simple way a little bit later on, but it's important to know how to do this too. So let's keep going. So we're going to learn about 4 different types of lines. Slopes of lines in the coordinate plane. You have negative slope, which falls from left to right as line J. Positive slope rises from left to right as in line K. Zero slope is a horizontal line, such as line L. And an undefined slope, which is vertical as in line N. I'm going to go ahead and explain that the way I like to explain it here. So, first off, we have negative slope. I like to always think of slope as in a ski slope, okay? And we always read our ski slopes from left to right, okay? So, from left to right here, this is a negative slope, meaning it's going downhill. Down, negative, okay? Correlate it like that. Little skier dude heading downhill. Next, we have a positive slope, okay? Cross-country skiing. He's going uphill from left to right. So just think about it that way. Next, we have a zero slope, which is horizontal. It's going 0 up, 0 down. I think that makes sense. And then lastly, an undefined slope. If you're a skier, you don't like to just free fall for forever. Maybe like 20 feet, I don't know. I'm more of a tree rider. I don't really do the cliffs and stuff, but whatever. Anyways, help. He's free falling because it's undefined vertical slope, okay? Anyways, let's go ahead and keep going. So example 1, they want us to find the slope of line B and the slope of line C. So let's go ahead and write our equation for slope right here. Slope equals rise over run, which is change in y, over change in x. Sorry, it's x sub 1, x sub 2. Okay, so if we go ahead and look at our blue line, the B, let's go ahead and just do this point first. This is y of 1, x of 0. So y1 is going to be 1, and it's going to be over, oops, sorry guys, y is 1 over our x, which is going to be 0, minus, if we go here, our b value is going to be up 1, 2, 3, 4, 5, 6, 7, minus 7 over 1, 2, 3, minus 3. Okay, so this is going to equal negative 6 over negative 3, which equals 2 over 1 if we divide them both by 3, which equals 2. So our slope of B is 2. Okay. Then let's do C. you could tell just looking at C, I'm just going to say it, C is 0 slope because it's flat. I guess we could do the work just real quick. C equals, is going to be up 3 over -3, and then minus up 3, because this point is 3, and positive 1, 2, minus 2. So that would be 0 over -5, which equals 0. If you ever have 0 in the numerator, it's going to be equal to 0. Okay, like I said, that's not the way I'd prefer to do it, because this takes a lot more time than if I pick 2 points on the line like they did, and I can simply just count from here. This is change in y. So the first thing we do is let's look at line B. It's a positive slope because we could tell from left to right it's going up. And we can count up 1, 2, 3, 4, 5, 6. Okay? So we saw it went up 6, and it goes over from this point where it went straight up 1, 2, 3. 6 over 3, because those negatives cancel out, so 6 over 3. I like to count it. I think it's way quicker. Anyways, I hope that makes sense. Let's go ahead and keep going. So comparing slopes. When two lines intersect in a coordinate plane, the steeper line has the slope with greater absolute value. You can also compare slopes to tell whether two lines are parallel or perpendicular. Okay, a lot of times when you're comparing slopes, you could visibly see one will be steeper than the other, like that. So slopes of parallel lines, postulate 17. In a coordinate plane, two non-vertical lines are parallel if and only if they have the same slope. Any two vertical lines are parallel. So for them to be parallel, they have to have the same slope. Slope of perpendicular lines. In a coordinate plane, two non-vertical lines are perpendicular if and only if the product of their slope is -1. So if you multiply the two slopes and you come out to -1, they will be perpendicular. Another way you could say that is they have to be negative reciprocals of each other, where the reciprocal of a fraction is where you flip it over, you put the numerator in the denominator and the denominator in the numerator. And if it was a positive, you change it to a negative. If it was negative, you change it to positive. You just take the opposite reciprocals. We'll go over that a little more in the example. So they want us to find the slope of each line and state which line is parallel. So the slope of A, let's do it my method. We have 2 points here. It goes down 1 over 1, 2, 3, 4. So -1 over 4. B goes down 1 over 1, 2, 3. -1 over 3. Okay? And C goes down 1 over 1, 2, 3. C is. So the two lines that are parallel are going to have the same slope. So B is parallel to C. Not a bad example. I hope that makes sense. If you want to do it, change in Y over change in X, that's also acceptable. You would just have to plug in your values into the equation. Totally fine. It's totally up to you. And sometimes that is the like only choice. If it's not graphed, sometimes you just have to plug the values in. For example, right here, let's go ahead and do change in Y over change in X to find the slope of K. So K is going to equal 3 minus 2 over 0 minus 5, which is going to equal 1 over 5, -5. Yeah. Which is funny. Let's go ahead and graph that too. Sorry, I'm just thinking. So if we graph that, I'm going to graph it in red. We have 0, 3, 0, up 3. And then we have 5 and 2. which is going to be 5 and 2. Here we go. Sorry, that's probably terrible, but it's close enough. Now we have to find the perpendicular to that point. And perpendicular, like I said, is going to be the opposite reciprocal of this. So we have to find the slope of our new line. So the opposite reciprocal, flip the 1 and 5, so it's 5 over 1. And it was negative, so it's going to stay positive. So we know that the slope of our new one is going to be running in this direction, positively. We also know it has to go through the point 1, 2. So let's go ahead and graph that point 1, 2. 1, 2. Right here. Okay? And we know it's 5 over 1, so it's going to go up 5 over 1. So we're going to count, oops, sorry. Not my laser pointer. 1, 2, 3, 4, 5 over 1. So it should be right here. 1, 2, 3, 4, 5 over 1. Okay, and connect those 2 points. And the blue line is going to be perpendicular to the red line. Hope that makes sense how we did that. If not, watch it again, and let's keep going. So, example 4. Rodney drained the water from the old tanks at 3 farms before installing new tanks. The graph shows the amount of water in each tank from the time the water began to drain until the tank was completely empty. Which statement is true? So, A says the tanks all began draining at the same time. He drained the tanks at different farms. It doesn't say what time he started draining any tank. So it's doubtful that they all started draining at the same time, especially since it doesn't state that. So we cannot assume A is true. Tank B was empty 4 minutes before tank C. Once again, we don't know what time they started, so we cannot say that is true. Tank C drained at the fastest rate. Well, if we look at the slopes, B has, pretty aggressive slope. A is not as sloped as B, but C is visibly steeper than B. So C drained the fastest. So that statement is true. And then D, tank A was larger than tank B. Once again, it doesn't tell us that information, so we cannot assume that is true. We just gotta make sure we read really careful and logically think through things. And yeah, let's keep going. A candle is lit at the center of the table at the beginning of a dinner party. Its height decreases by 1.75 inches every 25 minutes. At the beginning of dinner, the candle was 8 inches tall. Make a table showing the height of the candle at 25-minute intervals. So I already filled out time and 25-minute intervals, and then we need to fill in our height. So at time 0, it told us that the height of the candle was 8 inches. Then it decreases by 1.75 inches every 25 minutes. So it would be 6.25, it would be 4.5, and 2.75 at 75 minutes. Okay? Yeah. Make sure you write these down because we're going to use these numbers again probably in the next slide. Or actually I do believe I have this written down already, so we're good to go. Let's keep going. A candle is lit at the center of the table at the beginning of a dinner party. Its height decreases by 1.75 inches every 25 minutes. At the beginning of the dinner, the candle was 8 inches tall. Same information we had on the last slide. Write a fraction that represents the decrease in height for each minute the candle burns. What does the numerator represent? So, if we look, we're told that the height decreases by 1.75 inches every 25 minutes. We want to know for every 1 minute. So if we divide, let's go ahead and write this down, 1.75 over 25, and that's negative. If we divide the both top and bottom by 25, that'll tell us per minute how long it took to burn. So if we do that, we're left with this equals negative 0.07 over 1. Okay? So that is a fraction that represents how much it burns each minute. Now, they want to know what the numerator is representing. Well, the numerator is actually representing the slope in decimal form. So it represents slope in decimal form. Okay? Yeah, let's keep going. We're almost done. Last one. So same information, it decreases at a height of 1.75 inches every 25 minutes. The candlestick is replaced with a thicker candle when dessert is served. It burns with a slope of 20.5 starting at a height of 5 inches. Use a graph to compare the way the candles burn. Which graph is steeper? So here you have a graph of the first candle burning and the second candle burning. So if you were to look at this, which candle is burning at a steeper rate? Obviously, the graph of the second candle is steeper. So there you go, guys. Hope all that made sense. Most of this is a review from algebra, so I probably blew through it a little too fast. I hope you guys are doing good and just keep up the good work and see ya!